What is a decant?
To pour off a liquid from a solid sediment.
How do our brains tell time?
Until very recently, scientists presumed, and it's not clear that there were many experiments to support this, that our brain had a stopwatch of sorts built into its machinery. By stopwatch, scientists meant some biological system that created some signal at regular intervals. If this were true, we would be equally good at estimating short and long periods of time. But that's totally not the case. Humans are pretty awful at guessing how long extended periods of time are. Instead, Dean Buonomano at UCLA proposed in 2007 that our brains tell time in a different way. To steal his analogy, imagine a rock being tossed into a lake, which creates a series of ripples in the surface of the water. If you were to throw a second rock in, the ripples from the two rocks would interact with each other. The pattern of this interaction depends on the time between the two rocks hitting the lake. The firing of neurons, the rocks hitting the lake, create these unique patterns in there. Signals and neurons can use the different patterns of signals interacting to tell time between events. The wonderful piece of this theory is that it explains why we're good at telling time over short durations, but not long ones over a long time. The ripples in the water just fade away.
What is electrochemistry?
Electrochemistry is a branch of chemistry that deals with electrons transferring between an interface and a molecule in an electrolyte solution. The interface is typically a conducting metallic material. Electrochemistry is a rich field that has led to the development of batteries. A widely used chemical separation technique called electrophoresis, a process for plating metals known as electroplating, and an immense body of knowledge surrounding oxidation reduction chemistry, among other achievements.
What is a shell?
A way of classifying the orbitals in which electrons can reside based on their principal quantum number.
What is a cation?
A cation is a positively charged atom or molecule. Cations have a larger number of protons than electrons, such that they have a net positive charge.
What holds nuclei together?
The nucleus of an atom consists of neutrons, which are unchanged charged, and protons, which are positively charged. while the unchanged arged neutrons don't feel an electrostatic attraction or repulsion to other particles. The positively charged protons should repel each other. In fact, this repulsive force between the protons is quite strong. Because protons in the same nucleus are very close together. Thus the force that holds them together must be a very strong force. Indeed it is, and it's even named the strong force. This strong force acts only over distances on the order of 10 to 15 m, a very short distance. If the protons were to become separated by a more substantial distance, the strong force would decrease in magnitude faster than the repulsive force, and the protons would be pushed apart. It's also often said that neutrons act as a sort of glue to help bind all of the neutrons and protons together. Since there seem to be favored relationships between the number of neutrons and protons present in stable nuclei,
Mitchell, United Kingdom, win the Nobel Prize for Chemistry?
for his contribution to the understanding of biological energy transfer through the formulation of the chemiosmotic theory. Mitchell received the prize for developing a theory of how electron transfer was coupled to ATP synthesis during oxidative phosphorylation and photophosphorylation. He proposed that a gradient of proton concentration, and thus also charge, was built up across the mitochondrial membrane, and that the reverse flow of protons down the concentration gradient provided the driving force for ATP synthesis. This is what is known as the chemiosmotic theory. Why did Herbert C.
What is quantum mechanics?
The branch of physics that describes the motion and interactions of subatomic particles.
What does it mean when we say a chemical reaction takes 1 minute?
When we say a reaction takes 1 minute, what we're really saying is that a certain fraction, specifically that fraction is 1-1/e, or about 63%, of the reactant molecules have gone on to form products after 1 minute has passed. E refers to the irrational number E equals 2.7182818. If we say a reaction takes 1 year, or any other amount of time, we're also referring to that same fraction of reactants becoming products. It's not that 100% of the reactants have become products, but rather just a certain fraction.
What are Bronsted acids and bases?
The Bronsted acid/base definition differs somewhat from the Lewis definition. Rather than focusing on electron acceptors and donors, the Bronsted definition deals with donating or accepting H and atoms, protons, In chemical reactions, a Bronsted acid is a species that tends to donate protons in a chemical reaction, while a Bronsted base is a species that tends to accept those protons. To accept protons, a Bronsted base must typically have at least one pair of non-bonding valence electrons.
What is the crystal field theory?
A model used to describe the electronic structure of transition metal molecules, particularly the energy of the d orbitals.
Is melting a chemical reaction?
No, melting is not a chemical reaction. Melting is a change between phases of matter, and it does not involve the breaking or formation of any new chemical bonds. As the temperature increases to cause a substance to melt, the arrangement of the molecules in the solid/liquid changes, but no chemical reaction takes place. The same is true for liquid to gas phase changes as well as for the reverse processes. Freezing and condensing.
What is hygroscopic?
A substance that readily absorbs water from its surroundings.
What is a salt?
An ionic compound that can be thought of to form from the neutralization of an acid or base.
Is starch different than cellulose?
Starch is also a polysaccharide, like cellulose, but it is much less crystalline. The major component of starch is amylopectin, which is a highly branched polymer, while cellulose is strictly linear. These branches prevent amylopectin from crystallizing as well as cellulose. Starch is an excellent source of energy, or stored sugar, for plants and animals for these reasons. Because it is less crystalline than cellulose, it is more soluble than cellulose. And the branched structure also means there are more end groups at which enzymes can start chewing the polymer apart.
Which elements are liquids at room temperature?
Actually, there are only two elements that are liquids at room temperature, mercury and bromine. Bromine is a diatomic compound, Br2, while mercury is a liquid metal.
How is a condensation polymerization reaction different?
Addition polymerization reactions do not involve the loss of any atoms from the monomer, but condensation polymerization reactions do. The molecule that is lost is almost always water.
What is a chemical change?
A process that alters the arrangement of atoms in a substance.
What are the basic units of pressure?
Unlike units of length and temperature, pressure is reported in at least 6 common units. The Pascal, abbreviated Pa, is the official standard unit, but bar, millimeters of mercury, mmHg. Standard atmospheres, atm, torr, and pounds per square inch, psi, are all used in different areas.
How does crystallization purify compounds?
Crystallization as a purification technique relies on the fact that it is usually much easier to form a crystal from a single chemical species than it is to form a crystal from a mixture of chemical compounds. Recrystallization is the process of dissolving a crude, impure product in a hot solvent or mixture of solvents, and allowing it to crystallize out of the solution form as the solvent cools. Once a small crystal, even one so small we can't see it, begins to form, it is relatively easy for other molecules of the same compound to add to the crystal. Other compounds will not be able to readily add to this crystal, which results in the formation of a crystal containing a single, pure chemical compound.
What is a covalent bond?
The equal, or near equal, sharing of electrons between two or more atoms.
Who first realized that oxygen gas, O2, was required for fire?
Philo of Byzantium in the 2nd century BCE was the first to observe, or at least the first to record such an observation, that if you placed a jar on top of a candle with water around its base, some water would be drawn up into the jar as the candle burned and eventually went out once all the oxygen was consumed. Although the experiment was well designed, he ended up with an incorrect conclusion about the process. Robert Boyle repeated the experiment but replaced the candle with a mouse. Seriously, and noticed the water also rose up the container. From this experiment he correctly inferred that whatever the component in air was, he called it nitroairus, it was needed for both combustion and respiration. Robert Hooke, and others, likely produced oxygen gas in the 17th century, but didn't realize it was an element as the phlogiston theory, see below, was in vogue at the time. So to really realize that oxygen gas was required for fire, it first had to be, well, discovered.
What does that mean?
Average kinetic energy is a precise way of saying how fast something is moving. In this case on a molecular level. The faster molecules vibrate, the hotter they feel because heat is being transferred from the object to your hands.
What is a metalloid?
Metalloid is a term for elements that are sort of metals, and sort of not metals. Sometimes this group of elements is referred to as semi-metals. To be more precise, these elements exhibit some of the physical and chemical properties of metals. Generally metalloids have some electrical conductivity, but not nearly as much as true metals. Because of these ambiguous definitions, even which elements are called metalloids can vary. Usually boron, silicon, germanium, arsenic, antimony, and tellurium are included as metalloids, sometimes polonium and astatine, rarely selenium.
What is the Coulomb's law?
Law describing the force between a pair of charged particles separated by a distance.
What is an evaporation?
Conversion of a liquid into a gas.
Why do organometallic complexes make good catalysts?
Catalysts, by definition, provide a lower energy route to the product. Organometallic complexes react with organic molecules in ways that are very different than how organic molecules react with themselves. At the most basic level, this is because transition metals have d orbitals that are involved in making and breaking chemical bonds, with additional orbitals that are of different symmetry than the sand p orbitals that are available to elements like carbon, nitrogen, and oxygen. Organometallic complexes can accomplish feats that are just impossible, forbidden, for other elements.
What is a detection limit?
The detection limit for a measurement is the lowest amount of signal that can be distinguished from the background level of noise. The detection limit is commonly reported with a confidence level describing the percent confidence with which the measured signal at the detection limit can be stated to be above the noise intrinsic to the experiment.
Why did George A. Allah, United States/Hungary, win the Nobel Prize for Chemistry?
For his contribution to carbocation chemistry. Carbocations are species that contain one or more positively charged carbon atoms. While these types of intermediates were postulated for years to play key roles in organic reactions, it was never believed that they could be isolated, due to the fact that they should be highly reactive. Allah managed to prepare stable carbocations through the use of extremely acidic compounds, which are actually called superacids. Allah's work thus revolutionized research into carbocation chemistry, as these species could finally be characterized for the first time. This work has been very influential in better understanding the role of these important intermediates in organic chemistry.
What is a phase?
A state of matter, e.g., solid, liquid, or gas.
What is the flash point of a substance?
The flash point of a substance is the temperature above which it can form an ignitable vapor in the air. This requires an ignition source. The vapor may no longer burn if a source of ignition is not present.
Why does iron rust?
Rust is iron that has been oxidized. The oxidation of iron, or any iron alloy, see History of Chemistry, can occur whenever iron is in the presence of oxygen and water. The chemical reaction involves electrons from the iron being transferred to oxygen atoms, which react with water molecules to eventually form iron oxides. The presence of ions, like salt or H3O and in acidic solutions, can accelerate the rate of these reactions. Preventing rust usually requires a protective coating that prevents the iron from reacting with oxygen and water.
How many nuclear power reactors are there in the world, and how many are currently under construction?
There are currently 436 nuclear power reactors around the world. The breakdown of the distribution by country is shown in the table below. Aside from the United States, a few other countries with large numbers of nuclear reactors are France, Russia, China, Japan, and Korea. Each of these nations has at least 20 nuclear reactors currently in operation.
What is a carbanion?
An anion in which a carbon atom bears a significant fraction of the negative charge.
What is volatile?
A substance that easily evaporates at normal temperatures and pressures.
How is O2 transported through the body?
Oxygen enters our body through our lungs in the air we breathe. O2 makes up about 21% of the total volume of air on Earth. From the lungs, O2 diffuses into the bloodstream, where it binds to a molecule called hemoglobin in our red blood cells. The binding affinity of O2 to hemoglobin is pH dependent such that oxygen can readily be picked up by red blood cells near the lungs and then released into tissues and other areas of the body that need it.
Is the speed of light always the same?
The speed of light actually depends on what material the light is moving through. Each material has a property called an index of refraction. From the index of refraction, we can calculate the speed of light passing through a material from the following equation, V equals C/N.
What is a noble gas?
Group 18 of the periodic table. Characterized by their general inertness due to their complete valence shell of electrons.
What is the antibonding orbital?
Orbitals in which the component atomic orbitals are out of phase, leading to repulsion or destabilization.
What is a free energy diagram for a chemical reaction?
A free energy diagram is probably easiest to understand by taking a look at one. See diagram, as we explain the key features. The y-axis measures the relative free energy of the chemical species we're dealing with, while the x-axis describes the reaction coordinate. It's common that going left to right is forward progress in the reaction. But this isn't necessarily the case 100% of the time. On the left we have our reactants. In general there may be any number of reactants, and here we've just denoted two species, A and B. The hill in the middle is the energetic barrier to the chemical reaction, and the quantity EA denotes the height of this energy barrier. The quantity EA is commonly referred to as the activation energy for the reaction. On the right-hand side of the diagram we have our products. Again, there can be any number of products, and here we've denoted them C and D. Finally we have the quantity G. which describes the change in Gibbs free energy associated with the reaction. The fact that the reactants are higher in free energy than the products tells us that this particular example is a spontaneous reaction. If the reactants were lower in free energy than the products, the reaction would not be spontaneous.
How are isotopes made?
Specific isotopes of an element can be obtained in one of two ways. Either by separation of the desired isotope from a naturally occurring sample or by synthesis of the desired isotope. Since the different isotopes of an element all have the same chemical properties, they can be quite difficult to separate. The separation techniques used to separate different isotopes are thus based on their differences in mass, rather than on differences in chemical properties. Some of the methods used include separation by diffusion in the gas or liquid phases, centrifugation, ionization, and mass spectrometry, or chemical methods based on differences in reaction rates due to different atomic masses. Different isotopes of an element can also be generated synthetically. One way to do this is to fire high-energy particles at the nucleus of an atom. Depending on the situation, this can either cause a particle to be emitted from the parent nucleus, generating a lighter nucleus, or the fired particle can be absorbed, generating a heavier nucleus. It is also possible to synthesize isotopes of some elements by making use of another naturally occurring nuclear reaction, such as when the particles released by one nuclear fission reaction are absorbed by another nucleus.
Why did Sidney Altman, Canada, United States, and Thomas Sek, United States, win the Nobel Prize for Chemistry?
For their discovery of catalytic properties of RNA. While RNA was already known for its role as a molecule involved in heredity and the transport of genetic information, Altman and Sek discovered that RNA can also serve biocatalytic functions. This was a completely surprising result to the scientific community. The discovery was made when RNA was put into a test tube in the absence of any protein enzymes, and the RNA began to cut itself into pieces and rejoin the pieces back together again. This observation led to the discovery of the first RNA enzymes. By the time the prize was awarded, nearly 100 RNA enzymes had already been discovered.
Why did Linus Carl Pauling, United States, win the Nobel Prize for Chemistry?
For his research into the nature of the chemical bond and its application to the elucidation of the structure of complex substances. Pauling made significant progress toward understanding the nature of chemical bonds, which are, obviously, relevant to virtually all chemical processes. he proposed the property of electronegativity as a means for characterizing chemical bonds. And he developed a scale for electronegativity values. Pauling's work with X-rays also uncovered the structures of numerous molecules, and paved the road for X-ray diffraction as a characterization method for even more complex molecules. In 1963, Pauling also was awarded a Nobel Peace Prize. Throughout his career, Pauling was always known for working and living at the forefront of scientific discovery.
What is PP, polypropylene?
If instead of substituting a chlorine atom we add a methyl group to each ethylene monomer, we get polypropylene. Recall from earlier that this introduces stereochemistry along the polymer. We've already mentioned that the arrangement of the methyl groups along the polymer chain can have large effects on the melting point and other physical properties. You can likely find polypropylene all over your house, from dishwasher-safe food containers to synthetic carpets, especially outdoor carpeting, and an increasing weight fraction of your car, including the bumper and the casing for the battery. It can also be made into ropes, which are quite strong and resistant to weather. So they are frequently used in fishing and farming. Polypropylene is also used for many medical applications because it is capable of withstanding the high temperatures required to sterilize.
What is a lipid?
A biochemical molecule that is hydrophobic or amophilic, e.g., waxes, fats, vitamins A, D, E, K, glycerides, etc.
What is meteoric iron?
Meteoric iron is just what the name sounds like, it's iron that comes from meteors. For early civilizations, meteoric iron was one of the few available sources of relatively pure iron. That is, prior to when the extraction of iron from ore was discovered. Meteors containing meteoric iron are composed of mostly nickel-iron alloys. Iron meteorites often have a distinct appearance, and they are typically much easier to recognize than other types of meteorites. For this reason, they are discovered more often than other types of meteorites. Iron meteorites actually account for all of the largest meteorites that have been discovered.
What was nylon first used for?
The first commercial application was probably toothbrush bristles. For centuries toothbrushes were made of coarse animal hairs, usually boar. Until DuPont, R., introduced Dr. West's miracle toothbrush in 1938.
What are the wavelength and frequency of light?
The light we see is a form of energy called electromagnetic radiation. It may sound like something complicated, but it's nothing too exotic or unfamiliar. Everything you see is because of electromagnetic radiation. Electromagnetic radiation consists of perpendicular electric and magnetic fields that oscillate in amplitude. The number of times per second that the fields oscillate is the frequency of the radiation. This is measured in hertz, or inverse seconds. The wavelength is the distance that the light travels through space during one oscillation of the electric or magnetic field.
How can reactions be run in a solvent-free environment?
There are a few common ways to avoid the use of solvents when running a chemical reaction. The simplest situation is when one of the reagents can serve as the solvent for the reaction. This is commonly referred to as running a reaction neat, yes, like Scotch. Reagents that are not liquids at ambient temperatures can also be used in the molten state so that they can be used as solvents. Some reactions can also be run on solid supported catalysts that do not require a solvent. By avoiding the use of solvents, each of these approaches cuts down on costs and on the amount of waste generated.
Where do we get uranium?
Uranium is mined largely in Kazakhstan, Australia, and Canada, although the U.S., South Africa, Namibia, Niger, Brazil, and Russia are also significant producers. Uranium is mined using a leaching process that allows it to be dissolved from ore deep in the mine and then pumped to the surface, where it is extracted and concentrated for use.
What is bagasse?
After sugarcane stalks are crushed and pressed to remove their juice, the remaining plant matter is known as bagasse. After the water is removed, and bagasse can contain a lot of water, bagasse is mostly composed of cellulose, hemicellulose, and lignin. Typically this material is burned by the sugar mills directly to generate heat for other processes running at the mill or electricity, which can also be used at the mill or sold back to the electric grid. Bagasse also finds its way into paper production. Recently bagasse has been targeted as a potential source of ethanol.
What is carbocation?
A cation in which a carbon atom bears a significant fraction of the positive charge.
What are some of the worst nuclear disasters in history?
A few of the worst nuclear disasters in history are those which took place at 3 Mile Island in the USA in 1979, at Chernobyl in the Ukraine in 1986, and more recently following an earthquake in Fukushima, Japan, in 2011. Nuclear disasters are very dangerous if they do occur. And the possibility of a nuclear disaster represents a primary reason that some people oppose the construction of new nuclear power plants.
Are all polymers linear chains?
No, and this is another way that chemists classify these really big molecules. The major types of polymer shapes, technical term. Topology, are linear, branched, and cross-linked networks. Linear polymers are chains of monomers joined together, like a noodle or a rope. If there is a point along a polymer chain where a second chain starts, like a fork in the road, this arrangement is referred to as branched.
Why did Lord Alexander R. Todd, United Kingdom, win the Nobel Prize for Chemistry?
For his work on nucleotides and nucleotide coenzymes. Todd laid the foundation for future research in biochemistry, genetics, and biology surrounding the structures and roles of nucleotides in living organisms. He established the chemical structures of nucleotides and established the, extremely important, role of phosphorylation in biochemical processes.
Which energy sources are renewable?
Renewable energy sources include wind, hydroelectric, solar, biomass/biodiesel, and geothermally derived power.
What is the current model for the atom?
The current model for the atom consists of negatively charged electrons orbiting a positively charged nucleus. The nucleus consists of neutrons and protons that are very tightly bound to each other by a strong force. Orbiting electrons behave something like a cloud surrounding the nucleus. And we can't be sure quite where they are at any given time. The electrons are also very lightweight compared to the nucleus, and they move much, much faster.
What is fiberglass?
Fiberglass is a polymer made from a plastic matrix that is reinforced by fibers of glass. It is a popular material because it is inexpensive to make, and its strength and weight properties compare favorably against those of metals for many applications. Fiberglass has a wide range of applications and is commonly used in glider aircraft, boats, cars, showers and bathtubs, roofs, pipes, and surfboards.
What is genetic engineering?
Genetic engineering is the process of changing the genetic makeup of cells or organisms to produce versions with specific traits or to produce new organisms altogether.
Why does drinking alcohol make people loopy?
Alcohol, specifically ethanol, CH3CH2O, is a mild depressant that affects your central nervous system. The specific biological effects are pretty complicated. Some systems are enhanced by ethanol. Others are inhibited. This combination of effects is why drinking can relax your muscles but also make you more animated. It may seem that alcohol lowers your inhibitions, but some experiments suggest this is a psychological effect and not a chemical one.
What is a superalloy?
Superalloys are alloys that display a particularly excellent ability to resist deformation under stress at high temperatures, along with good resistance to corrosion and great surface stability. Most often, a superalloy involves nickel, cobalt, or nickel iron as the base alloying element. Superalloys have been used primarily in turbines and in the aerospace industry.
What is my credit card made of?
Also PVC, but for the material in credit cards, no plasticizer is added. To manufacture a credit card, usually a few thin sheets of PVC are glued together.
What is an atom?
Smallest unit of a chemical element.
What is the Boyle's law?
Law stating that the pressure and volume of gas are inversely proportional.
What was the first chemistry textbook published?
Although numerous chemistry texts exist before it, Alchemia, published by Andreas Libavius in 1597. is considered to be the first organized chemistry textbook. Libavius, born in Halle, Germany, in 1555, was a chemist and a medical doctor, and also served as a schoolmaster at the end of his life. In addition to his noteworthy textbook, Libavius is significant in the history of chemistry for further advancing the discipline away from the realm of magic, the occult, and alchemy toward a teachable, logical, and scientific discipline.
How are the Fahrenheit, Celsius, and Kelvin temperature scales related?
The Celsius and Kelvin scales use the same size degree. Incremental scaling is the technical term, but set their zero values at different absolute numbers. Let's explain that sentence a bit more. If you go up by 1 degree Celsius or 1 degree Kelvin, you've raised the temperature the same amount, but 0 degrees Celsius, the temperature at which water freezes, is 273.15 K. Thus the two scales are offset from one another by 273.15. Fahrenheit is completely different though. Water freezes at 32 degrees Fahrenheit, and a change of 1 degree on the Fahrenheit scale is equal to a change of 0.55 degrees Celsius.
What are some examples of experimental error?
Say, for example, we use a stopwatch to record the lap times for a race car driving several laps around a track. Our measurements of the lap times will be affected by the quality of the stopwatch. Our ability to accurately operate the stopwatch during each lap, as well as variations in the ability of the race car driver and car to maneuver around the track.
What are some industrial processes that make use of catalysts?
The chemical industry uses catalysts in a staggering array of chemical reactions that make products that we all use every day. The production of ammonia, NH3, from nitrogen, N2, and hydrogen, H2. Known as the Haber-Bosch process, uses iron or ruthenium catalysts. This reaction is used to generate about 500 million tons of fertilizer per year. Most of the world's plastic is made by one form of catalysis or another. And the refining of crude oil into gasoline and other fuels is also possible because of catalysts. Catalysts are also used in food processing and production. Margarine is made by reacting fats with hydrogen gas in the presence of a nickel catalyst.
What determines whether a particular type of nucleus can be monitored by NMR spectroscopy?
Similar to electrons, nuclei can have a net spin, or spin angular momentum. NMR spectroscopy can be used to study any nucleus that has a non-zero spin angular momentum. Some common nuclei that chemists study by NMR are 1H, 2H, deuterium, 13C, 11B, 15N, 19F, and 31P.
What is an alpha particle?
A particle consisting of 2 neutrons and 2 protons, i.e., a helium nucleus.
What is absorption?
Capture of one material into another, can be a physical or chemical.
What is PET, polyethylene terephthalate?
Polyethylene terephthalate is a thermoplastic that is used in both textiles, where it's called polyester, and in bottling, where the same polymer is called PET. PET is an alternating polymer of ethylene and terephthalate monomers. This material is really good at preventing gases from diffusing through it. So it's great for keeping carbonated drinks fizzy.
What is a molecular dynamics simulation?
Molecular dynamics simulations are a computational model of a collection of molecules that interact with one another under a specified set of conditions, temperature, pressure, etc. While electronic structure theory calculations typically only involve one or a few molecules, molecular dynamics simulations can involve hundreds or thousands of molecules all at once. The purpose of molecular dynamics simulations is typically to investigate how molecules interact and react while surrounded by a collection of other molecules. While the energies of individual molecules can be investigated by electronic structure theory, a molecular dynamics simulation allows theoretical chemists to also study how molecules are influenced by their surroundings. These effects can be especially important in liquids, where solvent molecules can have a significant impact on reactivity.
What is an atomic orbital?
Atomic orbitals are mathematical or pictorial descriptions of the locations of electrons in an atom. Electrons are tricky particles to understand because their location isn't easy to define. They can be thought of as clouds of negative charge surrounding a nucleus. And atomic orbitals describe the shapes of these clouds. Atomic orbitals can take on different shapes and sizes, but are essentially very similar from one element to the next. The number and type of orbitals that contain electrons play a central role in determining the properties of that atom.
What is a mole fraction?
The amount of a substance in moles divided by the total number of moles present.
What about beet and cane sugar? How are those different?
Beet sugar comes from sugar beets. Cane sugar comes from sugar cane. After these two sugars are purified, refined, there is no chemical difference.
What is exothermic?
A process or reaction that releases heat.
What is a polar?
A compound in which the charge distribution leads to an overall dipole moment.
When was Avogadro's constant discovered?
Amedeo Carlo Avogadro published a paper in 1811 describing his theory that a volume of gas at a given temperature and pressure contains a certain number of atoms or molecules regardless of what gas it is. Avogadro didn't actually determine what that number was, however. It took just over 50 years for someone to make progress on that. Johann Joseph Loschmidt, in 1865, estimated the average size of molecules in air. It's nothing short of amazing that he ended up being off by only a factor of 2. Jean Perrin, a French physicist, accurately determined the constant using a few different techniques. He was awarded the Nobel Prize in Physics in 1926 for the work. But Perrin proposed that the constant be named for Avogadro and the name stuck. For more on the use of the constant, see atoms and molecules.
What is electronegativity?
Electronegativity is a property that describes the tendency of an atom to attract electrons in a chemical bond. The most electronegative atoms are those which pull hardest on the electron density they share in a bond with another atom. There is more than one scale and definition for electronegativity, and our description here follows that given by Linus Pauling, which is the most commonly used scale in chemistry courses. Electronegativity can most readily be described in terms of the number of protons in the nucleus of the atom and the distance to which its valence electron cloud extends away from the nucleus. As a general trend, the most electronegative atoms are those with the shortest distance between the valence electrons and the nucleus. Electronegativity isn't a physical quantity that can be directly measured, but several scales have been developed that derive values for this property based on other measurable physical quantities.
What is group theory and how is it useful in chemistry?
Group theory, in the chemistry sense, involves making use of the symmetry of a molecule to better understand its physical properties. By examining the symmetry properties of a molecule, it can be placed into a point group that describes the symmetry operations. Rotations of reflections, that characterize the molecule's symmetry. Group theory allows chemists to understand an impressive number of molecular properties, including the spacing of energy levels of the orbitals in a molecule, the symmetry of the molecular orbitals, the types of transitions that can occur, like vibrational and electronic excitations, and what the delocalized vibrational motions of a molecule look like. It is very impressive that symmetry can tell us so much about molecules without the need for any complex calculations.
What causes the glow in glow sticks?
Glow sticks contain three main components: a dye, diphenyl oxalate, and hydrogen peroxide. The hydrogen peroxide is the chemical you release when you crack or activate the glow stick. Diphenyl oxalate reacts with the hydrogen peroxide to generate a molecule called dioxydenadiene. This particular molecule decomposes to release two molecules of carbon dioxide and energy that excites a dye molecule to a higher energy state. To get back to its stable state, the dye releases a photon of light, making your glow stick glow. The particular structure of the dye molecule controls the wavelength, color of this light, which is how you can get glow sticks in different colors.
What is quantum mechanics?
Quantum mechanics is a branch of physics that is needed to provide an accurate description of objects with very small mass, such as electrons. It does so using an approach that describes matter as being both similar to a particle and similar to a wave. The description of a particle in quantum mechanics is contained in something called a wave function, which can be related to the probability of an object being in any of its possible states. One interesting and counterintuitive thing we learn from quantum mechanics is that for particles with very small mass, the position, velocity, and other quantities defining the state of the particle cannot all be precisely specified at the same time. The wave-like description offered by quantum mechanics is needed to explain why molecules have discrete energy levels, along with many other experimental observations from physical chemistry that are inconsistent with classical mechanics.
What is a homogeneous mixture?
A sample containing only one, pure substance.
What does hydrophobic mean?
A nonpolar molecular that does not interact with water.
What compound was the first to be analyzed by proton NMR?
The first recorded example where the shifts of the different nuclei in a molecule were separated by chemical shift was ethanol, CH3CH2O.
What is an anion?
An anion is a negatively charged atom or molecule. Anions have a larger number of electrons than protons such that they have a net negative charge.
Why did Walter Hermann Nernst, Germany, win the Nobel Prize for Chemistry?
For his work in thermochemistry. Nernst made several somewhat related contributions to chemistry surrounding the specific heats of compounds at very low temperatures. The use of galvanic cells and the ability to calculate chemical affinity from thermochemical properties. And surrounding variations in chemical equilibria at different temperatures. Nernst's most significant gift to chemistry can be stated succinctly by saying that he and his co-workers helped to make possible the calculation of whether a reaction will take place to a significant extent under a set of known conditions. Nernst also was the first to formulate the third law of thermodynamics.
What is matter?
Any substance that has mass.
What is sublimation?
Phase transition from solid to gas without passing through the liquid phase, e.g., the smoke that dry ice gives off.
What is nonpolar?
A molecule in which the distribution of charge does not lead to an overall dipole moment.
Why did Peter Ager, United States, win the Nobel Prize for Chemistry?
For discoveries concerning channels in cell membranes for the discovery of water channels and Roderick MacKinnon. United States. For discoveries concerning channels in cell membranes for structural and mechanistic studies of ion channels. Agar received half of this prize for isolating a membrane protein that serves as a water channel in cells. For roughly 200 years it had been postulated that cells contained channels capable of moving water in and out of cells. But Agar was the first to finally discover a concrete example of a water channel. Mackinnon received the other half of this prize for his work on ion channels, and in particular for his characterization of the spatial structure of a potassium channel. For the first time, this allowed chemists to see how potassium ions flowed in and out of cells.
Why did John Warkup Cornforth, Australia, United Kingdom, win the Nobel Prize for Chemistry?
For his work on the stereochemistry of enzyme-catalyzed reactions, and Vladimir Prelog, Yugoslavia/Switzerland. For his research into the stereochemistry of organic molecules and reactions. Cornforth explored the stereochemistry of enzyme-catalyzed reactions by using isotopically labeled hydrogen atoms to study the geometry of their arrangement in the enzyme's active site. Prelog studied how the stereochemistry of organic molecules affected their reactivity, leading to important discoveries. He also explored the stereochemistry of enzyme-catalyzed reactions, observing how they reacted with simple organic molecules. Why did William N.
What is the difference between eukaryotes and prokaryotes?
Prokaryotes are organisms whose cells do not have a nucleus, while eukaryotes are organisms whose cells do have a nucleus. Prokaryotes are most often, but not exclusively, unicellular, single-celled organisms. In addition to lacking a nucleus, they also lack other separate membrane-bound organelles. All of the proteins, DNA, and other molecules in a prokaryotic cell float around within the cell membrane but are not separated into different compartments. Eukaryotes do typically have separate membrane-bound organelles within their cells. They may be single-celled or multicellular organisms. Every large organism, animals, plants, fungi, is eukaryotic, and many small and single-celled organisms are in this category as well.
What is an electron?
The electron is a negatively charged subatomic particle, and it is one of three main subatomic particles, the others being the proton and the neutron, that make up atoms. Electrons are responsible for bonding atoms together to make molecules, and they are also the carriers of electric charges in the conducting materials found in the electronic devices you use every day. While protons and neutrons are both found in the center, or nucleus, of an atom, electrons are located apart from the nucleus and are best described as a cloud of electron density. Most reactions in chemistry deal with changes to the arrangement of electrons in some form.